This video goes over the double angle identities. So cos 2a actually has three separate identities that we use. Cos squared a minus sine squared a. We also have 2 cos squared a minus 1. And then we have 1 minus 2 sine squared a. Sine has one identity, 2 sine a cos a, and then tan 2a is 2 tan a over 1 minus tan squared a. So what we're going to do is we're going to practice doing some algebra and evaluating the trig ratios for double angles. So in this first example, we're given that cos theta is equal to 5 over 13, and theta is in between 3 pi over 2 and 2 pi. So the first thing I'm going to do is draw out what that says. So between 3 pi over 2 and 2 pi, that is in the fourth quadrant. It also tells me that theta is 5 over 13. So 5 is my adjacent side, 13 is my hypotenuse. 5 is also my x side, 13 is my r, and this missing side here is my y. What I'm going to do is I'm going to find the missing side of that triangle using the Pythagorean theorem. So I know that y squared is equal to 13 squared minus 5 squared. Y squared is equal to 144. Y is equal to 12. We are going to use the positive value because we are looking for a side length. Once I've found that value, I'm going to list the values for my other primary trig ratios. So I know that sine theta is y over r. In this case, I have 12 over 13. I'm also in the cos quadrant, so that means my sine ratio is negative. Cos theta is x over r. I was given that one. That one is 5 over 13. And then I have tan theta is y over x. This one is also negative. My y value is 12. My x value is 5. Now I'm going to use these primary trig ratios combined with my identities to find the value of cos 2 theta, sine 2 theta, and tan 2 theta. So let's start with cos 2 theta. The one that I'm going to use is 2 cos squared theta minus 1. And what I'm going to do is I'm going to replace cos theta here with my value for cos theta that I calculated. So that means that cos 2 theta is 2 times 5 over 13 squared minus 1. Now I can evaluate that to be 2 times 25 over 169 minus 1. 1 I know I can change to anything, so I'm going to change it to be 169 over 169. When I simplify that, 50 take away 169, I'm going to get minus 119 over 169. I'm going to repeat the same process for sine 2 theta and tan 2 theta. So sine 2 theta is 2 sine theta cos theta. And I'm going to replace sine theta with the value of the ratio that I found initially, and I'm going to replace cos theta with the value of the ratio that I found initially. So 2 times minus 12 over 13 times 5 over 13 is going to give me minus 120 over 169. And then finally, I'm going to find tan 2 theta using my last identity of 2 tan theta over 1 minus tan squared theta. And what I'm going to do is I'm going to replace tan theta here and here with the value of the ratio I found for the principal angle initially. And so I've got 2 times minus 12 over 5 over 1 minus 12 over 5 squared, which is going to simplify 2 minus 24 over 5. And then I'm going to change this to 25 over 25 minus 144 over 25. When I simplify that, I'm going to get 120 over 119. So the next part of this question is to ask where the terminal arm of 2 theta is equal to. And so what I know is that cos 2 theta is less than 0. I know that sine 2 theta is less than 0. And I just found that tan 2 theta is greater than 0. The only quadrant where all three of those things is true is in the third quadrant, the tan quadrant. So I'm going to say that since tan 2 theta is greater than 0, the terminal arm is in Q3. So we're going to do one more example with 2 different identities over here. These are the ones that we used from before. And so this time I've got 2 different angles. I've got A and B. And so I'm going to start off by finding the primary trig ratios for both of those. So for A, I know that A is in the first quadrant between 0 and pi over 2. I also know that it's equal to 3 over 5. So 3 is my y side, 5 is my radius. I'm looking for the missing side, which is x. This is going to be 5 squared minus 3 squared using the Pythagorean theorem. I know that my missing side is equal to 4. I'm going to just use the positive side because I know I'm looking for a side length. And then I'm going to set up my primary trig ratios. So sine A is given to me in the question. Cos A is my adjacent side over the hypotenuse. And then tan A is going to be my opposite side over the adjacent. I'm going to repeat the same thing for B. Cos B is minus 8 over 17, and B is in between pi and 3 pi over 2, so that is this quadrant over here. 17 is my R, and 18 is going to, or 8 is my X value, so I'm looking for my missing Y. So I know that Y squared is 17 squared minus 8 squared. This is going to give me 225, which means that my missing side is 25. And now I can set up my trig ratios for B. So we are in our tan quadrant, so only tan is positive. So sine B is going to be my y value over the hypotenuse. It's going to be negative. Cos B, I'm given in the question, which is minus 8 over 17. And then tan B is the opposite side, which is 25 over my adjacent side, which is 8, and that ratio is positive. So next, I'm going to use my addition identities to figure out what each of those values are. And so the first one that I'm looking at is sine of A plus B. I know that that identity is going to be sine A times cos B plus cos A times sine B. And so I'm going to replace those values with the trig ratios that I calculated. So sine A is this ratio. Cos B is this ratio here. Cos A is this value. And finally, sine B is this value up here. So I'm going to make those replacements. Sine A is 3/5. Cos B is minus 8 over 17. Cos A is 4 over 5. And then sine B is minus 25 over 17. When I simplify those, I'm going to get as my final answer minus 84 over 85. I'm then going to repeat the same process for cos A plus B using my identity, my addition identity, which is cos A cos B minus sine A sine B. And I'm going to replace those values with the values of the primary trig ratios that I calculated before. So I have cos A, cos B, sine A, and sine B. So cos A is 4 over 5, cos B is minus 8 over 17. Sine A is 3/5, and sine B is minus 25 over 17. When I simplify those together, I'm going to get 13 over 85. And then I'm going to repeat one more time to get tan of A plus B using my identity of tan A plus tan B over 1 minus tan A times tan B. And I'm going to replace these values. So tan A with my primary trig ratios that I calculated originally. So I've got tan A and tan B, and I'm going to make those replacements using the values of the ratios, and then simplify. So tan A is 3/4, tan B is 25 over 8, and then on the denominator, I have 1 minus 3/4 times 25 over 8. When you simplify that, I'm going to get minus 84 over 13. Finally, I can use these values to figure out the location of the terminal arm of A plus B. And so if I go back up, I know that sine of A plus B is less than 0. Cosine of A plus B is going to be greater than 0. And then tan of A plus B is also less than 0. The only quadrant where all three of those things are true is in the cos quadrant. So I would say since sine of A plus B and tan of that same angle are less than 0, and cosine of A plus B is greater than 0, the terminal arm of A plus B is in the cos quadrant, which is the fourth quadrant.